Hello, today we're going through HCF and LCM. So my first question for you is, what is a prime number? So the definition of a prime number is a number that can be divided by 1 and itself only, and if divided by something else will result in a non-whole number. So we can see this through numbers 1 to 10. I'll highlight which ones are prime numbers. So 2 is a prime number, 3 is a prime number, 5, 7, and those are all the prime numbers from 1 to 10. So you may be wondering why 1 isn't a prime number. So in the definition, it says that a prime number is a number that can only be divisible by 1 and itself. And the factors of 1 are only 1 times 1. So in the definition it's saying that it has to be 2 factors. This is only 1 factor, so 1 is not a prime number. 4 is not a prime number because 4 is the same as 2 times 2. 6 is not a prime number because it's the same as 2 times 3, and etc. Next we're going to find out how we can find the prime factors of 2 numbers. Now I'm going to use the example 60 and 42. I'm going to use these numbers throughout the video using different methods. So let's start with 60. If we split 60 into 2 factors, we can say that 6 times 10 equals 60. So 6 and 10. So now we focus on 6. What do we times together to get 6? 2 and 3. Now if you notice from the line I made earlier of 1 to 10, 2 and 3 were prime numbers. So we're going to circle those. 10 splits into 2 and 5. So I'm going to circle those. Next I'm going to do 42. That splits into 6 and 7. 7 is a prime number, so I'll circle that right away. Now I only have 6 to do. And that splits into 2 and 3. So now I know what the prime numbers are, but I want to write it more clearly. So I'm going to say that 60 is equal to 2 times 2 times 3 times 5. Now I'm going to say 42 is equal to 2 times 3 times 7. So now we've expressed these numbers as a product of their primes. Okay, next we're going to try and find the HCF and LCM. So HCF stands for highest common factor and LCM stands for lowest common multiple. So I'm going to go through the first method. And the first method is using a Venn diagram. So a Venn diagram is 2 circles or 3 circles in some cases. And I'm going to say that this circle is going to be 60. This circle is going to be 42. So if we go to these prime numbers, you can say that both of these numbers share 2 and they share 3. So we're going to write 2 once in the intersect, we're going to write 3 once in the intersect. So for 60 that leaves us with 2 and 5, so we're going to write 2, 5, 42, that leaves us with 7. So to find the HCF, we times whatever is in the intersect. So HCF equals 2 times 3, which equals 6. LCM is equal to all the numbers times together. 2 times 2 times 3 times 5 times 7. Okay, so that is method 1. Next we're going to go through method 2, which is a fancy method called the Euclidean algorithm. So Euclid was a mathematician from 300 BC, and the word algorithm you might see in computers. Algorithm is usually a process or a set of steps used to solve a problem. And we're going to use it to solve for the HCF of 60 and 42 first. So the formula is A equals B Q plus R. Now this is confusing at first, but basically we have two numbers, 60 and 42. So we're going to take whichever is bigger from these numbers, and we're going to put 60 as A. We're going to say B is 42. We're going to put bracket Q plus R. So what you do for each step is you do 60 divided by 42 in long division. So that is 1, remainder 18. So we put the 1 as Q. So 60 equals 42 bracket 1 plus remainder 18. So we've done that. Now our next step is we move this number to this and 18 to where 42 is. So we say 42 equals 18 Q plus R. So we do some long division again. 42 divided by 18, so that's 2, remainder 6. So we say that 42 equals 18 times 2 plus 6. So then we repeat the process again. We move 18 to where 42 is and 6 to where 18 was. We add R, we divide it, 18 divided by 6, that's 3. So 18 is equal to 6 times 3 plus remainder 0. So this is where you know that you've finished the algorithm. So when the remainder equals 0, you have to go up to your last step of working to where 6 is, and that will be the HCF, which we worked out earlier. So the HCF of 60 and 42 is 6. So using the Euclidean algorithm, we've worked out the HCF, but we haven't worked out the LCM. So to work out the LCM, we can use a useful rule saying that the product of the two numbers, so 60 times 42, is equal to the HCF times LCM. So the HCF is 6 and the LCM is unknown. So we're going to rearrange the equation. LCM equals 60 times 42 over 6. So if you put this in your calculator, it's 420.